Hello everyone, welcome to this presentation where we're going to be looking at how we can use SRAM to generate enclosed structure wind loads according to NBCC 2020 provisions. This capability is also available for ASCE 7 2022 and supplements the existing seismic load generators within SRAM. So the model that I'm using right now, you can see, is a large steel structure representative of a big box store. And this was built using the multi-story builder in SRAM. And one important thing to note here is that when using the multi-story builder, we will automatically be able to generate our floor IDs for our structure. In this case here, I have 3 stories, and you can see story number 1 is at the base. Maybe if I toggle off the display of my supports, we'll be able to see that a bit more clearly. Then I go story 2 above that, story 3, and so on. It's important that we have this to differentiate each story. We should start with story number 1 and work our way up in sequential order without any gaps. And to set up our wind loading, I can actually start by going to the settings menu. And under the settings menu, I can go to preferences, drag this over to my other monitor, and click on design codes. Here I can specify which building code I'm using. I'm going to use NBCC 2020. And you'll notice that at the bottom, we have 2 different tabs, one for earthquake loading and one for wind loading. So I'll click on the W tab for wind loading. And there are various parameters that allow us to specify our wind coefficients. You can see here we have the option to enter velocity, pressure, our importance factors, and so on. We also have this exposure type. Notice that it's set to none by default. And when it's set to none, that means that we'll have to enter the windward and leeward exposure factors, CE, right here. However, if we choose one of the other options, for example, this open exposure type, we don't have to enter that, and the program will automatically calculate that based off of the terrain type. We also have the ability to specify our wind pressure coefficients, CP, as these are being user-defined, or they can be determined by the program. And in this situation here, I'm going to determine them, let the software calculate them for me. Now, when I'm doing this, it's important to note and maybe remind ourselves that we have different size floors, if that makes sense. So our bottom floor obviously expands the entire plan view of our model, whereas the top floor doesn't quite extend the entire way. So we actually have different L over B aspect ratios that are going to vary along the building height. And when we let SRAM determine this, it's going to calculate it's going to use the smallest ratio for all the floors, which leads to the highest wind pressures. So I've got this option here to say program is going to determine this wind pressure coefficient for us. I'll click OK. I'm now going to go into the loads window, and under the loads window I can see my existing load cases. But what I'm most interested in doing now is going to the edit menu, and under the edit menu I can see there's this option here that says generate enclosed structure wind loads. We also have an open structure wind load generator according to API specifications, if that's of the type of structure and design code that you're looking for. However, in this case, I'm going to be using the enclosed structure wind loads. From this dialog that appears, I then have the option to generate just the lateral loads, or torsion plus lateral loads, or all of those. I also have the option here to update my existing load cases from a specific point if I already had these generated for me. I have to then enter which load case number I want to start this update from, because again, it's going to generate up to 12 load cases, so we have to make sure that we're starting from a logical point. I'm just going to say let's generate these from scratch. I'm going to generate all of them, and I'm going to give it a wind load base load case name. I'll click the OK button, and it's letting us know here that it's got to generate a wind force joint, basically where that wind is being located on the actual floor system. In my particular model, I have rigid diaphragms defining the floor system, and I also have area load span directions assigned to those. But the advantage of using the rigid diaphragms is that any of those lateral loads are then going to be automatically transferred to the diaphragm constraint and all the other lateral force resisting structure. However, in the absence of rigid diaphragm, we may want to look at where this wind force joint is being created and make sure it's connected to our structure in a logical fashion. So I'll click OK. And maybe I'll just display some of my loads here so I can just work with this existing load case number 12 and toggle on the display of my joint loads. And we can see here there's 2 joints in our model. that are loaded. So I'm just going to zoom in on these. And there's quite a bit of data behind this, so maybe what I'll do instead actually is just switch to the joint load tool, untoggle this, and I'm going to look at my X-force loads. And I can see the magnitudes of each of those. I've got quite a few decimal digit displays on in this model here, which I can always revise. But here I can see the X-force direction loads, and where they're applied I can see the Y-force direction loads, and also the Z moments as well, because there is the opportunity for eccentricities and so on that are specified through the design code implementation. And we have a number of other load cases that have been created. Each of them will have their own set of loads that might vary from case to case depending on the combination of loads that are being applied. So hopefully this gives you a bit better understanding for how this works. If you're looking for more information about our load generators in S-Frame, or perhaps using the ASCE 7 wind load generators, you can certainly check out our YouTube channel at Altair How To find more information.